We're continuing our discussion of the graphs of trigonometric functions, and this should be the final one. In this video, we're going to talk about the graph of the cotangent function. So again, I've provided you with a unit circle, and our function is y equals cotangent. And a couple of things to remember here about cotangent. First off, it is actually the reciprocal of the tangent, so we would have 1 over the tangent of x, or you could think about it as being the cosine of x divided by the sine of x. Okay, so you can look at it either way. So to help us out here with our values, I have given you the values for the tangent, and so then we have the idea of the reciprocal, which is flipping it over. So if we take a look at, again, focusing on the values on the unit circle, and we take a look at the cotangent of 0, okay, the reciprocal would be 1 over 0, or again, you would have cosine over sine. And we've talked numerous times about how that's a problem because you cannot have 0 in the denominator of the fraction. So at 0, the cotangent is undefined. Then if we take a look at the cotangent of pi sixth, okay, that gives us tangent is 3 square root 3 over 3, so the cotangent would be 3 over the square root of 3. Again, we flip it, but again, we know we can't have a radical in the denominator, so I'm going to multiply the numerator and the denominator by the square root of 3, okay, which is going to give me 3 on the square root of 3 over 3. And then I'm able to simplify that because I have a 3 in the numerator and a 3 in the denominator, so the value becomes square root of 3, which in a decimal is approximately 1.7. For pi fourths, the cotangent of pi fourths, the reciprocal of 1, you would have 1 over 1, which is still 1. For pi thirds, the cotangent of pi thirds, again taking the reciprocal, you would have 1 over the square root of 3. Here again, you cannot have a radical in the denominator, so you need to multiply the numerator and the denominator by the square root of 3, which ultimately gives you the square root of 3 over 3. And in decimal form, that's approximately 0.6. So the cotangent of pi thirds is square root 3 over 3. Now, it might be a little bit tricky at pi halves, so let me see if I can help you out here. Okay, for the cotangent of pi halves, the tangent is undefined. So if we look at our cosine over sine in this idea, here we have the cosine is 0 and the sine is positive 1. So the cotangent of pi halves would actually be 0. Once you have that first quadrant, remember then we can simply rotate around the circle using the same values but altering the sign. In the second quadrant, the cotangent would be negative because you have a negative divided by a positive, which makes it overall negative. So at 2 pi thirds, we would have negative square root 3 over 3. At 3 pi fourths, we would have negative 1. At 5 pi 6, we would have negative square root of 3. At pi, when you take the reciprocal of 0, it's going to again be undefined. Then we're around into the third quadrant, And in the third quadrant, you're going to have a negative cosine divided by a negative sine. So a negative divided by a negative is going to be a positive. So the third quadrant, the cotangent is positive. So at 7 pi 6, you would have the square root of 3. At the cotangent of 5 pi 4, you would have 1. The cotangent of 4 pi thirds would be positive square root 3 over 3. Then you're back to 3 pi halves, which is undefined, so we may want to take a look at that one. Okay, so the cotangent of 3 pi halves, again using the idea that it's cosine over sine, you would have 0 over negative 1, which ultimately simplifies to 0. And then I'm around into the fourth quadrant, and in the fourth quadrant, the cotangent, I have a positive cosine divided by a negative sine. So overall, the cotangent would be negative. So 5 pi thirds, the cotangent of 5 pi thirds would be negative square root 3 over 3. The cotangent of 7 pi fourths would be negative 1. The cotangent of 11 pi sixths would be negative square root 3. And then 2 pi is the same as 0, so it's going to be undefined. And here again, remember, you're going to have asymptotes wherever you have it undefined. So let's see if we can take a look at the graph of cotangent. Again, being the reciprocal of tangent. Okay, so let me draw the axes here. You have your vertical axis, which is your y, and you have your horizontal axis, which is your x. We typically label them initially, at least with the quadrantial angles, 0, pi halves, 1 pi, 3 pi halves, and 2 pi. We could also rotate negatively. Then on the vertical, we typically put our 1 and negative 1. Okay, so then if we go back and look, we'll notice that at 0, at pi, and 2 pi, so it looks like every pi units we're going to have a vertical asymptote. So we have an asymptote, it's undefined at 0, it's undefined at pi, and it's undefined at 2 pi. Then if we go back and look at pi halves, we're at 0, and at 3 pi halves, we're at 0. So now I'm at 0. And I need a few points in between. Normally we don't have to label points in between, but we need a couple of extra points here because that doesn't really give us anything. So I'm going to look at the halfway point. So halfway between 0 and pi halves is pi fourths. Halfway between pi halves and 1 pi would be 3 pi fourths. And so if I take a look at those points, you'll find that at pi fourths, your value is 1. And at 3 pi fourths, it's negative 1. So you're going to get a curve that kind of comes down. Remember, it stays between the asymptotes and looks something like that. So again, if I look at the other values, between the next ones, I would have to add, let's see, 5 pi fourths and 7 pi fourths. So I have negative 1, or excuse me, positive 1 and 1 and then it curves down. And I can also draw it on the other side because, again, we figured out that every pi units, whether it's positive or negative, you're going to have an asymptote. At the halfway point, we're going to be at 0. We add in our other values, and you kind of get this S-shaped curve that's between the asymptotes. Okay, and those do continue to go on forever and ever. So typically you're going to draw arrows on either end to show that it goes on forever and ever in both directions. Okay, so there's your picture of cotangent. Now, another thing to consider is how far do we have to travel to get the entire picture? Well, you'll notice if we start with an asymptote, we end with an asymptote, and then at the halfway we were at 0. So we really get one full picture, one full curve of the cotangent if we travel 1 pi. So the period for cotangent, similar to the period for tangent, is only 1 pi. Remember, for all the other functions, for sine, cosine, secant, and cosecant, the period is 2 pi. But for tangent and cotangent, it's only 1 pi. So let's look at some characteristics of the cotangent. It is a function. It will pass the vertical line test. We can use any number we can think of except multiples of pi. So at 1 pi, 2 pi, 3 pi, 4 pi, and so forth, you're going to have vertical asymptotes. The range is all real numbers because it does go on forever and ever in both directions. It is periodic, and again, the period is 1 pi. It is odd or symmetric to the origin. Your zeros occur at odd multiples of pi halves. There is no relative minimums or maximums because, again, it keeps growing in or increasing or decreasing. And there's no y-intercept. It doesn't cross the y-axis. There happens to be a asymptote at the y-axis. And again, our asymptotes occur at multiples of pi. Again, with cotangent, since it's the reciprocal of tangent, most researchers would tell you that you're able to use cotangent wherever you can use tangent. And I suppose they're reasonably interchangeable. Again, we tend to use tangent just because it's a more commonly used one than cotangent. But again, kind of the thing to remember so that you have that basic shape in your mind. Cotangent begins with an asymptote, ends with an asymptote, mids at 0, and then it is a decreasing function, whereas the tangent was increasing.